Hello, welcome to Sidtronics. In this video we will learn how monostable configuration of 555 IC works. We will also build our own circuit by the end of this video. First, let's understand the basic function of this configuration. This configuration is used to produce time delays ranging from approximately 1 millisecond to as high as 10 minutes. This delay time can be adjusted by changing values of some components used in the circuit. We will talk about it later in this video. Let's first build the circuit, then understand how it works. I will use this rows as power lines for our circuit, so let's first connect them together. Now connect 555 IC on a breadboard, but make sure that the notch of the IC faces correct direction. Now connect pin 1 of IC to negative rail and pin 8 to positive rail. These pins are used to power the IC. Now connect pin 4 of IC to positive rail of breadboard. We need to tie this pin high because it is an active low pin. It can accidentally reset the IC if left floating. Now we need to connect push button on breadboard. But be careful, if you are using push button similar to the image, then make sure that interconnected pins go into the same row of the breadboard. This groove in between separates the interconnected pins of button. Now connect pin 2 of IC to one terminal of button. We need to use a pull-up resistor between same terminal of button and pin 1 of IC. Now connect other terminal of button to negative rail. Connect pin 6 to pin 7 through a wire. Connect a 10 microfarad capacitor between pin 7 of IC and ground. But, make sure that anode of capacitor is connected to pin 7, and cathode is connected to ground. This is an optional step, but you can use a 10 nanofarad capacitor between pin 5 and ground to eliminate any noise on output pin. Now connect a 1 mega ohm resistor between pin 8 and pin 7 of IC. Now connect anode of LED to pin 3 of IC, then connect cathode of LED to ground through a current limiting resistor. Our circuit is complete. Now let's connect the power supply. I'm using 5 volts here. You can use anywhere from 4.5 volts to 15 volts. Now before testing our circuit, let's first understand how it works. This is block diagram of 555 IC. I will explain this in a different video. Now let's understand the function of its pins. These are pins for power supply. Through these pins we power the IC. Pin 2 and pin 6 are used for controlling the output pin. These pins can basically sense the voltage applied on them. If pin 2 detects voltage below 1/3 of VCC, then the output pin of IC turns on. And at the same time discharge transistor turns off. As a result, discharge pin of IC kinda disconnects from IC. And similarly, if pin 6 detects voltage above 2/3 of VCC, it turns off the output pin and at the same time discharge transistor turns on. As a result, discharge pin of IC goes low. Pin 4 is reset pin. As I mentioned earlier, it is active low pin, which means if it detects low voltage on it, it will reset the IC and force the output pin to go low. This pin should be tied high when not in use. Pin 5 is control voltage pin. This pin can be used to change reference voltage level of trigger and threshold pin. It is recommended to connect this pin to ground through 10 nanofarad capacitor, when not in use. Now let's understand how our circuit works. In this circuit, trigger pin is held high using pull-up resistor R2. Thus output pin stays low and so does discharge pin. As discharge pin is low, current will flow from resistor R1 to discharge pin. Capacitor C1 will also discharge through this pin. So, voltage, at this point is almost zero. At this point our IC is in stable state. To turn on the output we need to push the button. Once we push the button, current will flow from pull-up resistor R2 to ground. As a result, voltage at this point will be almost zero. This will trigger the pin 2, as it is less than 1/3 of VCC. As a result, output pin of IC will go high. And LED will light up. Output will stay high even after the switch is released. This is due to internal latching mechanism of IC. But at the same time, discharge pin turns off, which will allow capacitor to charge through resistor R1. So voltage, at this point, will rise slowly until it goes above 2/3 of VCC. Once it goes above 2/3 of VCC, it will activate the threshold pin, which will turn off the output pin, and at the same time discharge pin will go low, and IC will return to the stable state. At output pin we get a pulse of certain time width. This time can be adjusted by changing these two components. Time width of these pulse can be calculated by the following formula. So let's calculate time width of our circuit. In our circuit we used resistor R1 as 1 megaohm, and capacitor C1 as 10 microfarad. First we need to convert these values in standard unit. After calculating we get time as 11 seconds. Okay, now enough theory, let's test our circuit. So according to our calculations, if I press the button, LED should turn on for 11 seconds. As you can see, LED turned off at around 11 seconds. But time width is not perfectly 11 seconds. This is due to tolerance of component values. Now let's change the capacitor and resistor which are responsible for time width. Values of R1 and C1 are now 100 kilo ohm and 47 microfarad, respectively. If we calculate time we get around 5 seconds. So let's test it. As you can see, LED turns off at around 5 seconds. We can replace the resistor R1 with a 100 kilo ohm potentiometer to change the time width easily. Before that I'm going to replace capacitor C1 to 100 microfarad capacitor, to get a larger range of adjustable time width. I am also adding a 10 kilo ohm resistor in series with potentiometer to act as minimum resistance when potentiometer is at 0 ohms. As you can see, we can now adjust time width without changing any component. In this circuit you can adjust time from around 1 to 12 seconds. If you want to even higher, adjustable time range, then you can replace the capacitor to a 1 with a higher value. That's all for today's video. I hope you learned something new. If you want more such videos, consider subscribing.